If you took the circumference of any circle and then divided that by 2 times its radius, you would always get the same answer, which is roughly 3.14, which most people know as pi. Virtually all of your equations for circles and all of your equations for spheres will utilize the symbol pi. The equation for the circumference of a circle is 2 times pi times the radius of the circle, and the equation for the area of a circle is equal to pi times the radius squared. Most of the time on a multiple choice exam, your answers will have the symbol pi in the answer choices. If not, and you want to estimate, you could simplify pi to be roughly 3. Sometimes a problem will give you the radius of a circle. Other times you have to figure out what the radius is. In this question they want us to figure out what is the circumference of a circle. So we're looking for what is 2 times pi times the radius. The only information they give us is that the area is equal to 64 pi. So we could write that equation as pi times the radius squared is equal to 64 pi. My pi's cancel out, and then I square root both sides, and I get my radius is equal to 8. From there, I take my radius and I plug that back into my circumference equation, and I get my circumference is equal to 2 times pi times 8, or my circumference is 16 pi. Most likely 16 pi will be your final answer, but if your answer choices were in decimal form, you could estimate 16 pi to be roughly 16 times 3, or approximately 48. When it comes to drawing an angle in a circle, there are 2 types of angles that you should be aware of. The first angle is called a central angle, and that's where the angle starts in the middle of the circle, or what we call the origin. When you have a central angle, the arc the angle cuts is going to be equal to the degrees of the angle. So for example, I drew this angle intentionally to be a 90-degree angle. And visually, if you look at it, it looks like I cut out 1/4 of the circle. Each circle has 360 degrees. So if I take 360 and times that by 1/4, I get 90 degrees. So the degree of my yellow arc is equal to the measure in my angle. But watch what happens when I draw that same 90-degree angle. This time I'm going to make it on the edge of the circle, known as an inscribed angle. Now look at the size of the arc the angle cut out of the circle. Visually it looks like that green highlighted part is half the circle. So half of 360 degrees would be 180 degrees. So the arc that I cut is twice as big as my original 90-degree angle. And that's always the case. When you have an inscribed angle on a circle, the arc the angle cuts is twice as big as the original angle, whereas a central angle cuts an arc that is equal to the degree measure in the central angle. So in this case, I have an inscribed angle cutting out an 80-degree arc. I should know that if my angle measure is x, the arc that I will cut is twice as big, or 2x. So I simply write the equation that 2x is equal to 80 degrees, or x is equal to 40 degrees. And all of this leads us to a special rule about triangles inside a circle. If we look at this triangle here, one of the sides of my triangle is the diameter of the circle that cut my circle in half. And that means the arc that was cut out by the inscribed angle in that triangle is exactly half of the circle, or 180 degrees. So if the arc that I cut is 180 degrees, that means my original inscribed angle must be exactly half of 180, or 90 degrees. Which then makes my triangle here a right triangle. And that's the rule. Anytime you make a triangle out of the diameter of a circle and an inscribed angle in that circle, you will always create a right triangle. There's one more term you should be familiar with, and that is tangent. A line is tangent to a circle when it goes next to the circle and just barely nicks the surface of the circle at exactly one point. If you draw a line from the center of the circle out to a tangent line, that line will always form a right angle with the original tangent. So let's see how that helps us with figuring out the angles in this triangle here. If this purple line here, if that's tangent, then I know I've actually formed a right angle with the radius of my circle. There's one more thing we didn't mention, but you should be aware of, and that is that the radius in any circle is the same no matter where you start and draw your line. So that means the radius in this circle here, this green line, that's going to be the exact same measure as this blue radius here. So that means the triangle I've created here is actually an isosceles triangle because two of my sides have the same length, which means two of their base angles are also the same. So if this angle is 63 degrees, that means my other angle is also 63 degrees. And because the overall angle created by my tangent line is 90 degrees, I know my smaller inside angle must be equal to 27 degrees. Additionally, I can see that on my right-hand side I have two angles that created a straight line. That means combined they must equal 180 degrees, or the larger outside angle will be equal to 180 minus 63, or 117. Finally, if I just look at the top yellow triangle, I know that all three angles should add up to 180 degrees. So I have my small angle of 27 plus my other angle of 117 plus my unknown angle that I'll call x. So my equation simply becomes 27 plus 117 plus x is equal to 180. Or 144 plus x is equal to 180, or x is equal to 36.